Okay, we're moving on to question 5. Question 5 is a geometry-based question with a little bit of algebra in it, so I guess it's a mixture. Let's see what they're asking us to do. They say leave your answers in insert form in this question, so very important. A and B are chords of the circle with center O. We stop reading. We told you O was the center of the circle. So immediately you can say that OD is equal to OC because of the radii that are being equal in a circle, and they are also equal to OB, which is equal to OA. Now they gave us an R here, so everywhere where there's a radius we can put an R because they told us that the radius is represented by the letter R. Okay, now folks, please don't make the mistake to think that all 4 of these angles are going to be equal to each other just because the sides are equal. We don't have equal chords. If the chords were also equal, then we could have argued that these triangles are congruent, and then the base angles will be equal. So the side opposite OD is angle C, the angle opposite side OD in that triangle. Opposite OC, there's angle D, so those 2 angles are indeed equal to one another. That's all we can say for now. And then the angle at A, you notice that I'm using different symbols because those are not equal. So these are lying in this bottom triangle, therefore those angles are indeed equal. We also have, staying at the center A, there's a line running from the center of the circle to the center of the chord CD. There's a theorem, your very first theorem, that tells us that that has to be a right angle, and that's what we're looking for there. Okay, if we have right angles, then we have Pythagoras that applies in triangles. Then here in the bottom triangle, the line from the center of the circle goes perpendicular to a chord in the circle, so we can immediately say that that chord has been bisected. That comes from your very first theorem that you'd learnt in grade 11. Okay, I think we can leave it at that for now. With the center, there's no angle at the center and an angle on the circumference that's subtended. So let's read on. AB is 12 units. We can stop. Let's go to the diagram. If AB is 12, then certainly that must be 6 and this must be 6 because that chord is bisected. Okay, we read on. CD there is 14. For the same reason, that will be 7 and this will be 7. And then finally, OE is 5 units. They gave that to us, that OE is 5 units. OE is perpendicular to AB. We've already used it because it was on the diagram. And here's one. OF bisects CD. CD is bisected by OF. Well, that was shown. So we used the visual cues that they gave us, and we saw that the angle here was 90. Okay, let's see what they ask us. We can move now to the question itself. Calculate with reasons the radius R. Now, if I want to calculate R using one of the top, I've got a challenge because there's an X. I don't know the X. Let's move to the other triangles. Well, I can find R because I have those 2 sides in a right angle triangle. Okay, so that's quite nice. We can just go straight into our triangle AOE or BOE. But remember, this became 6, so we got to start arguing there. So AB is equal to 6 units. That was given to us. But OE is perpendicular to AB. That was also given to us. Therefore, AE equals EB equals 6 units each, and we can say the radius was perpendicular to the chord, hence the chord has been bisected. Okay, and then clearly R squared is equal to 6 squared plus 5 squared, which is 36, plus the 25, and that gives us 61. And from there, the radius is the positive root of 61. Remember, if r squared is 61, you usually say it's plus or minus the root, but the radius is a positive idea, a positive concept. It's a length, so we only work with a positive. Now they ask us to calculate the value of x. Okay, we've got the radius. The radius in each of these is root 61. Now we can see we can calculate x, but remember the first thing that happened was that became 7. So again, as we did here, we've got to argue why it's 7. So let's start with OF is given. OF here bisects the chord CD. Therefore, that was given to us. Therefore, OF is perpendicular to the line segment CD. That is what we could say from there. Therefore, we can now have the OF and FD in any case was given equal to each other. So yeah, OF bisects CD, so that means that those two are equal. Therefore, we needed to argue the fact that this was perpendicular, because we're going to use the right-angled triangle. This was given to us, so that's 7. So we can say, therefore, x squared is equal to 61 minus the radius squared minus 49. And this is good old Pythagoras that told us this years ago. And then 61 minus the 49 is the only little bit of mental arithmetic you have to do. That gives you 12. 61 minus 49. Okay, folks, if you add 49 and 12, you get to 61. So finally, x, again being a positive because it represents a length, is therefore the square root of 12. We want simplest surd form. I almost forgot about that. Remember, 61 is a prime number. It cannot reduce anymore. So we can say 12 is 4 times 3. For those of you who forgot to do this, this will be 2 root 3, the value of x. Okay, so straightforward, not really problematic, that particular question.